Hey guys, I hope wherever you are safe and you're actually enjoying this time off this rainy Thursday morning. Today we're going to go into a topic about dividing polynomial functions. So underneath the topic, you can go ahead and put dividing polynomials. This is going to look a little bit different from the beginning of the year when we were dividing polynomials, we were simplifying rational. This is going to be more of using long division. There is a reason why we're going to go back to dividing polynomials because when we get in a case where we can't factor, we're going to use polynomial division along with the rational root theorem to find zeros for our polynomial function. So let's start off by reviewing what it meant to divide a monomial. This is when we simplify rational expressions. Go ahead and pause the video and simplify the number 1 and 2. Simplify those rational expressions. All right, guys, check your work. How many of you took a GCF out of the numerator and then canceled that GCF from the denominator? Okay, so the first one we had a GCF of 3x squared. I could cancel that in the denominator. Second one, GCF of 7ab. Cancel that from the denominator. Then I'm left with what's just in the numerator. If you remember your simplifying rational expressions, good job. Okay, so now we're going to go to the next step and we're going to talk about dividing. We're going to use factoring. Again, this is just review from what we did in the beginning of the year. Let's use factoring to divide out these polynomials. Here we go. I'm taking the first polynomial, w squared minus 7w plus 10. I want to go ahead and factor the numerator, and then I'll factor in the denominator. Well, actually, we already have that factored as w minus 5. Numerator product sum factoring two numbers that multiply to a positive 10, add to a negative 7. I am thinking w minus 5 and w minus 2. Okay, if I look at this, the w's are going to cancel. The w minus 5s will cancel from top to bottom. And so I'm left with only the polynomial w minus 2. Okay, dividing polynomials. Let's look at the next one. I take a 4h squared minus 7h minus 2 divided by h minus 2. Well, I'm just going to put that how we had this last one. I'll just write it 4h squared minus 7h minus 2 over h minus 2. And I'm going to factor the numerator, and then I'm going to cancel from top to bottom. Remember, this is just review for the beginning of the year. All right, I'm going to do my bottoms up factoring to factor the numerator. So I'm going to move that leading coefficient, which is not 1, to the back by multiplication. I end up with h squared minus 7h minus 8. Then I factor that like normal product sum factoring. Well, what multiplies the negative 8 and adds to a negative 7? Well, that is h minus 8 plus 1. Remember, I have to divide out that leading coefficient, which I do. And so I'm left with, if I simplify this, an h minus 2 times a 4h plus 1. And if I have to simplify, remember we cancel common factors from top to bottom. I am going to cancel those common factors. I end up with 4n plus 1. Now, let's move on. So why am I going over division of a polynomial? Well, because factoring is just a method of dividing polynomials. Okay, it's division. And what I want to do now, the reason why I want factoring is because we're finding zeros. We're in the business of finding zeros so that way we can know what the graph of a polynomial function looks like, because we know those zeros are x-intercepts. Well, sometimes we get a polynomial function like the one that I gave you for your zero check-in that is not factorable. I can't factor it. So what do I do when I need to find the zeros and for unknown reason my calculator is not working? I'm going to use this method called synthetic division. And synthetic division is very important because we'll use it in sync with the rational root theorem. We'll talk about this tomorrow, how they'll work together. But we're going to use it with the rational root theorem to find roots, which are solutions, which are x-intercepts, which are zeros for polynomial functions. So here we go. Let's talk about synthetic division. Now, I'll tell you, I'm not going to go over long division. You can X this out. We're going to do the following problem using synthetic division. The first thing I want you to do is write the steps of synthetic division. The first step is to take your linear factor, okay? And you're going to find the zero of your linear factor, all right? So that's step number 1. Find the zero of your linear factor. The second step is to place the zero in the box, and I'll tell you what that means. I'll show you what that means in a little bit here. The third step is to grab the coefficients of your other polynomial. Once you grab the coefficients of the other polynomial, you're going to write them outside of the box. Again, I'll show you what that looks like. Your next step, not almost at the last step, is to drop the first coefficient down. You're going to drop them down to a line you've drawn. I'll show you that in a second. Then you're going to multiply, then add, and then you're going to repeat this step until you reach the last column. So let's see this in action. Here we go. I have x squared plus 3x minus 43 divided by x plus 8. X plus 8 is my linear factor. I need to find its zero. So that means I'm setting x plus 8 equal to 0 first. And I'm going to solve for x. That means I subtract 8. Here is my zero. My zero is x equals negative 8. Step number 1, I found my zero. Step number 2, place the zero in a box. I am going to draw a box, and I draw it like a backwards L. That's where I'm going to place my zero, which is negative 8. Okay, so my zero goes inside of my box. The next step, grab the coefficients of your other polynomial and write them outside the box. I look at my other polynomial. I am grabbing only the coefficients. 1, which is the coefficient in front of x squared. 3, which is the coefficient in front of x. And negative 43. All right. Now it says to drop the first coefficient down to the line. Well, I have to draw a line, and I am going to drop my first coefficient down to this line. So my first coefficient is 1. The next thing that it tells me to do is multiply and then add and repeat until the last column. So what I'm going to do is I am going to multiply a negative 8 times 1. Negative 8 times 1 is negative 8. I am going to put that what my value underneath my second coefficient, and then I'll add. Okay, 3 minus 8 is negative 5. Then I'm going to multiply again. I keep repeating the steps. Negative 5 times negative 8 is 40. So I am going to put that under my next coefficient, and then I'm going to add, and in my result, I'm writing that sum on the line. Negative 40 plus, or negative 43 plus 40 is negative 3. I do that until I get to the end. Now there's the last step that I want to write. This is step number 6. Once you get to the end, you are going to drop in your variables. So drop in your variables. Starting with 1 degree less than what you began with. Okay? 1 degree less than what you began with. 1 degree less than what you started with. So what I'm saying, all right, so what do I mean by 1 degree less than what you started with? Well, we initially, if we look at the polynomial, we started with an x squared. So I'm going to now drop in variables with these coefficients 1 degree less, 8x to the first power. So I have a x minus 5 as my solution. Now this minus 3 here is what's called my remainder column. Your last column will always be a remainder column. It's either going to have a value or 0. What you do with the remainder is you do write it with your equation, but you put your linear factor underneath the remainder. So my linear factor x plus 8 is written underneath. Okay, so here's my answer. X minus 5 minus 3 over x plus 8. Okay, that is my solution. X minus 5 minus 3 over x plus 8. Let's try over here another example. Oh, this is the same one. Okay, so that's the same thing we did with synthetic division. Let's go ahead and try some other problems. Right. All right, guys. So this says use longer synthetic division, and we're going to just focus on synthetic division to divide the polynomial below. So let's go through our step. Remember, our first step is to take the linear factor and find its 0. So I'm going to go over here. I'm going to take n minus 7. I'll find the 0. Okay, that's by setting it equal to 0, solving for x. So adding 7, adding 7. My linear, or my 0, is going to be n equals 7. Now, I need to take that 0 and draw it in a box. So Miss Bennett draws her backwards L-shaped box, and that's where I'm going to put the 7. Okay? Then my next step is to grab the coefficients of my polynomial, my other polynomial. So I'm grabbing the coefficients, 2, negative 16, and 19. Then I need to drop the first coefficient down to the line. Well, that means I need to draw my line. All right, there we go. So I draw my line, and then I'm going to start dropping down the first coefficient. Okay, so 2 comes down to the line. I multiply, then add, and I keep repeating. So 2 times 7 is 14. And then I add negative 16 plus 14, that is 2. And then I do it again. 2 times 7, that is 14. And then I add, that's negative 14. Sorry, I forgot my negative. So that's negative 14. And then I add again, 19 minus 14, of course, that is 5. All right. My last step, remember, I drop in my variables and I do a degree less than what I have. Well, this is to the second power, so I'm going to drop in a n to the first. After that, I have nothing left. My last column is always my remainder column. I do write this inside of my solution, but remember I put the factor underneath. So this is over n minus 7. So here is my result, and I'll just write it out again so you guys can see how to write this. But my result is 2n minus 2 plus 5 over n minus 7. That is my solution. Let's go to the next problem. All right, we're going to go ahead and divide using synthetic division. First step, we take our linear factor and we're going to find its 0. So our linear factor is y minus 2. Let's find its 0. I am going to solve for y. And so I know the 0 is at y equals 2. All right. I am going to take the 0 and I'm going to put it inside of the box. Okay, so I put that inside of the box. And then I grab the coefficients. My next step, grab the coefficients of my other polynomial. Okay, so I got a 1, I got a 5, I got a -7, I have a 2. Then I want to drop my first coefficient down to the line. Okay, so I'm dropping it down to the line. That means that I needed that line. I needed to draw that line. Okay, so I'll drop 1 down. Then I'll multiply and add. So I'm multiplying 2, what's in my box, times the coefficient. 2 times 1, that's 2. I write it under my next coefficient. And then I add 5 plus 2 is 7. I write that on the line. And then I'll multiply again. 7 times 2 is 14. I write 14 under my next coefficient. And then I add those two together. -7 plus 14 is 7. I multiply again. 7 times 2 is 14. And then I add those two together, and that is 16. Now I'm going to add in my variables, and I do it 1 degree less than what I started with. I started with a degree 3. So I'm going to add in a y to the second power. That's 1 degree less. And I'm going to descend down. Y to the second, a y to the first, nothing here, right? Because that's now y to the 0 is nothing. All right. This last column I told you guys is our remainder column. So if there's something in the remainder column right here, remember we're going to put it over our linear factor. Y minus 2 is our linear factor. So our solution is y squared plus 7y plus 7 plus 16 divided by y minus 2. Sometimes when you're dividing polynomials and you get to step 3 where you're grabbing the coefficient, you'll have some powers missing. Okay, so notice here we're at a cube power, and then it goes straight to the first power. So we're missing that coefficient that would be with the square. It's important that you do not ignore that. We're going to place those missing coefficients. We're going to give them a placeholder of a 0, okay? Because we have to recognize that place is there. So let's go through the steps again. I am going to divide this synthetically by starting with my linear factor, k plus 5. I'm going to figure out what the 0 is of that linear factor. Again, I'm setting this equal to 0, solving for k. Okay, well, my 0 is k equals -5. I'm going to do the next step. I'm placing my 0 inside of my box. So -5 goes inside my box. And I need to do the next step, which is grab the coefficients of my polynomial. So I'm going to grab my coefficients. I got, with the k cubed, there is a 1. But remember, k squared is missing. So I'm going to do a placeholder of a 0 for that missing coefficient. Now we got k to the first power. That's -17. And then the plus the 32, positive 32. All right, now I can go ahead and I can draw my line and go through the steps. Again, I'm going to bring my first coefficient down to the line, and then we do the multiplication and add. I'm going to multiply times my 0 and then add the other coefficients together and do that over and over again. So 1 times -5 is -5. I write that underneath the next coefficient. 0 minus 5 is -5. Then I go through the steps again. -5 times -5, that's positive 25. And then I'm going to take -17 plus 25. That's 8. And then I'm going to take 8. I draw it on my line, and I take 8 times -5, and that's -40. And then I take 32 minus 40. Well, that's -8. Now I need to drop in my variables, and I start with a degree less than what I started with initially. My degree, my highest degree was 3, so I'm going to drop in variables a degree less. So this first coefficient will have a k squared. The next coefficient will have a k. And then the last coefficient is just, it is what it is, right? Because we don't have a k to the 0 power. We do look at our remainder column. Last column is a remainder column, and we do have a remainder. The remainder is -8, and I put that over k plus 5. I put it over my linear factor. So guys, my solution here, when I divided it, I ended up with a k squared minus 5k plus 8 minus 8 over k plus 5. All right, let's try it again with the problem below. Again, we're going to watch out for missing linear coefficients, and we're going, or not linear coefficients, but missing powers, and we're going to substitute a 0 in for those missing powers when we grab coefficients. So let's start with our first step. Set our linear factor equal to 0, okay? And we're going to find our 0. X minus 8 is our linear factor. Setting that equal to 0, add 8 to both sides. I end up with an x equals 8. I'm going to take that factor and I write it in the box, 8. And then I start grabbing the coefficients. All right, so I got an 8 for my x to the 4th, a -64 for my x to the 3rd. Notice my x squared is missing, so I'm going to put a 0 for my x squared. And then I got a 3 for my x to the first power. And then I got a -28. All right, now let's draw a line, and we're going to bring our first coefficient down to the line. And we'll start our multiplication and then addition. So I'll multiply times my 0. 8 times 8 is 64. I write it under my next coefficient and then I add. Negative 64 plus 64 is 0. Then I multiply. 0 times 8 is 0. And then I add. 0 plus 0 is 0. Then I'm multiplying again. 0 times 8 is 0. And then I add a 3 plus 0 is 3. Then I multiply again. A 3 times 8 is 24. And then I'm going to add a negative 24 plus 24 is a negative 4. Is a negative 4. And then I'm going to drop in, again, I start dropping in my variables, but I start with the degree, a degree under what I started with. So I have an x to the 4th. That means I'm going to start with a x to the 3rd power. And then I drop in my variables just descending down. The next coefficient gets an x squared. The next coefficient gets an x. And so on. I've ran out. I can't have an x to the 0 power. All right. Looking at my remainder column, which is always the last column. If there's something in the remainder column, it's a negative 4 in this case, I put it over my linear factor, x minus 8. So let's go ahead and write this out. Let's write it out. We have a 8x cubed, 8x cubed, plus 0x squared. Well, 0 times anything is 0. I don't have to write that. Plus a 0x. I don't have to write that either. Plus a 3. I do have to write my 3. Plus, or minus, in this case, minus a 4 over x minus 8. And that's it, guys. I want you to move on. You're going to do the assignment today, okay? And then I want you to upload your work for the assignment. So the assignment is your homework. Upload your work for the assignment. And then on Friday, we're going to get together for a session and we'll just do some practice. Again, come to the session. If you have questions, we can do some practice. All right, see you guys tomorrow.